All right. This is 9.7 special right triangles, but this time we're going to be discovering the 45, 45, 90. So this is the other half of that lesson. What do you have if you have 7 oranges in one hand and you have 8 oranges in the other hand? You have very large hands is what you have. So let's discover a special 45, 45, 90 right triangle. Okay, well, looking at this, 45, 45, 90 has to be an isosceles right triangle. So if it's isosceles right, that means it's a 45, 45, 90. Okay, so if we let one of the sides be x, the other side has to be x, we can figure out the missing side by using our friend Pythagorean theorem and figuring it out. Y squared is equal to 2x squared, root it. Y is equal to, well, you got root 2, and we did this in the last time. The square root of x squared is just x. So this side is equal to x root 2. Putting it together. Isosceles right. You don't need the 45s there if they mark it as isosceles right. Sides are x, x, and x root 2. Memorize it. You have 45, 45, 90. Smallest side is x, which makes the other side x, and you have x root 2. Not 2x, that's in the 30, 60, 90. All right, knowing that, let's superimpose this using that. You see this is a 45, 45, 90. So each side is x, x, this side is x root 2. So we're going to set x root 2 equal to 8. Solve it, divide by root 2's. Can't leave it in the denominator. Multiply top and bottom by root 2, you get 8 root 2 over 2. Does it simplify? That goes into there, so you get 4 root 2 for each side. Moving right along. Each side is x. Across from that, this is the x root 2 side. So, ooh, this side is 6 root 3. That's easy because it's the same. Plug this side in, you get 6 root 3 times root 2, giving you 6 root 6, and it doesn't break up, so you are done. Third one, 45, 45, 90. So you got x, x. This side is x root 2. So you set 6 root 5 equal to x root 2. Can't do anything, so you got to divide by root 2. Can't leave it in the denominator. Multiply top and bottom by root 2. So you get 6 root 10 over 2. Does the 6 and the 2 simplify? Yes, it does, giving you 3 roots of 10. That goes for this side over here, and this side over here. Hopefully I'm not going too fast for you. You seem to be pretty smart at these. So we got x, x, x root 2 once again. Ah, great. We have that side. So this side is 5 root 6, which means that over here we're going to set 5 root 6 times root 2, giving you 5 roots of 12. Are you allowed to leave that? Nope. You get 4 and 3, so you get 2 roots of 3, but you got the 5 in front. So this is 10 root 3. Okay, moving on. What do we notice? Oh, gotcha. This is not a 45, 45, 90. You should know that it ends up looking at it as a 30, 60, 90 triangle. So across from the 30 is x, the x root 3, and then we got 2x. So we're going to set 7 root 4 equal to x root 3. But wait a second, 7 root 4. Can that be simplified? Root 4 is what number? 2. So this side is actually 14. So we're going to set x root 3 equal to 14 and solve. Divide by root 3. End up getting 14 root 3 over 3. 3 does not go into 14, so that's this side over here. So the 2x side, multiply it by 2, ending with your 28 root 3 over 3. Once again, another 30, 60, 90. So you got x, x root 3, 2x. So we're going to set 10 equal to 2x. divided by 2. X ends up equaling 5. So this side is 5. Substitute in over here, 5 root 3, and we're done. Moving on to finish up, find the perimeter of a square. So we learned that an equilateral triangle breaks up into 30, 60, 90s. What do you think a square breaks them into if you know the diagonal's 15? Well, each angle started with 90, and it bisects the angle, so ta-da! The square is the figure that breaks up into two 45, 45, 90s. So we got x, and this side over here, which I'll put in green, is x root 2. So what are we going to do? We're going to set x root 2 equal to 15, divide by root 2, leaving it not in the denominator, so you get 15 root 2 over 2. But that's for one side. We have 4 sides, so we're going to get 60 root 2 over 2, which simplifies to 30 root 2 and some units for our perimeter. So it looks like another similar triangle as the last one. Or, I'm sorry, trapezoid is the last one for number 8, so we know that splits into making 6. We know that this looks like it's going to be a 45, 45, 90. But before we can do anything, we have to start over here with our 10. So this is where we set 10, looking at it. This is the 60 side up here, so here's x. This is x root 3, and this is 2x. So 10 is equal to 2x. X ends up equaling 5. So what do we know? This side is 5. This side is 5 root 3 down here. This side is 5. This side also has to be 5. This is now, instead of Pythagorean theorem like last night's assignment, this one is 5 and 5. And then what do we know? This side is the x root 2 side, so this is 5 roots of 2. Find the perimeter. We got 6, we got 10, we got 6, we got 5. Add it all up, that's 27. We have a 5 root 3. We also have a 5 root 2. These cannot be combined, so your perimeter is left at that. And yes, it is possible for you to get something like that on an assessment that we will be doing. Lastly, find the length of the median drawn to BC. Okay, well, let's draw the picture out first. We got A at 3, negative 2. 1, 2, 3, down 1, 2. There's point A. We have over negative 1, up 6. B. We got over C. We got 9, up 4. C. So when we draw this in, here's our figure. Triangle. Drawn to BC, so we want to know where is to BC. We want to find the length of the median. Well, first off, we have to find where that point is. So we know that this point is at negative 1, 6. This point is at 9, 4. So to find the midpoint, we add our x's up. 9 plus negative 1 over 2. And we do 6 plus 4 over 2, giving me 4, 5. This point right here. Well, we learned that if we want the length of something, what do? We learn distance formula. Big square root, x2 minus x1 square it, plus y2 minus y1 square it. Doing so, substitute the numbers in to the square root. So what do we get? We get 4 minus 3 square it, plus 5 minus a negative 2 square it. Big square root, this is 1 squared. Big square root, this is 7 squared. So what do we get? We get 1 plus 49, which is square root of 50. Simplifies, you get 25 and 2. Break it up. The length of it is 5 roots of 2 for your final answer. Hopefully that went well, and look at that. We did that in such a nice time. It was under 10 minutes. Have a good evening. Ta-ta for now.